Welcome back. Hey guys, welcome back to another video by Mallory. In this chapter, we're going to continue on in chapter 12 about health and medical research. In the chapter and section, we're going to talk about distributed disease research and the specific examples associated with it. So just a little introduction. Research into diseases is often carried out using computer models. These models often require a lot of computing power to produce the results needed. So one approach to this problem is a distribution of power through different computing systems to harness power of many computers. So that's where the Folding at Home project comes in. The Folding at Home project uses these techniques to understand folding and misfolding of proteins in the body, processes which are not well understood but are suspected to cause many diseases, including Alzheimer's, cystic fibrosis, JCD, and Parkinson's disease. So the Folding at Home model is actually set up at Stanford University. It's a major research project using distributed computing for disease research that stimulates protein folding, computational drug design, and other types of molecular dynamics. So the project uses idle processing softwares of thousands of personal computers. So what the volunteer can do, anybody at their home who doesn't use one of their personal computers or does use it, can download the software and help with the research going on. So it's pretty cool in that way. So the own volunteers who have installed software on their system. Its primary purpose is to determine the mechanisms of protein folding, by which proteins reach their first three-dimensional structure, and to examine the causes of the protein misfolding. This again has significant academic interest of the major implications for diseases, including cancer, which I didn't mention earlier. The Folding at Home project is also multifaceted in that it tries to predict the protein's final structure and to determine how the molecules may interact with it. This has applications in drug design. So not only can it be used to help maybe predict certain types of diseases and why they are caused, but it helps in the specific drug design. So again, the Folding at Home is developed and operated at the Pand Laboratory at Stanford University under the direction of Vijay Pand, and is shared by various scientific institutions and research laboratories across the world. So the project has pioneered the use of supercomputers and high-performance computing. The project has used GPUs, PlayStation 3s, message passing interface used for computing multi-core processors, and a lot of different technological means that have various high-performance computing power. Through this research, the project uses statistical simulation methodology that is a paradigm shift from the traditional computer approaches. As part of the client service network architecture, the volunteered machines each receive pieces of simulation or are, in effect, different work units. So through this overall simulation, the project can use many different computers to link it to the project's database servers where they're all compiled in the overall simulation. The cool thing about the volunteer project is that the volunteers can participate, and as well they can track their contributions on the website. And so the volunteers' participation can become competitive and also encouraging long-term involvement. So the Folding at Home project is one of the world's fastest computing systems. It has a speed of approximately 12 petaflops, greater than all the projects running on the BOINC distributed computing platform. So it has a lot of power, which is good because it's doing good and hopefully finding some causes to different diseases. The project was also the most powerful molecular dynamics simulators until about the mid-November 2011. So computationally it is expensive, but with the use of the volunteers it is really taking off, and over 100 scientific research papers have been written as a result of the Folding at Home project. Overall, the results have been favorable, although they haven't made any vast or drastic discoveries. They've had a few breakthroughs, and the Folding at Home project definitely needs to continue. These are some of my resources. Thank you for watching.